Okay, in this video we're going to investigate the distance formula. The distance formula in coordinate geometry. So what that means is, let's say I have, here's my x-axis. Let's say here's my y-axis. What we want to be able to do is to find the distance between 2 points. So let's say we have this point here, 1 over 1 up 1, so that's the point 1, 1, 1, 2, 3, 5. Here's my origin, 1, 2, 3, 4. Okay, so over 1, so over 1 up 1, and let's look at the point 4, 3. So this point is over 4 up 3, over 1, 2, 3, 4, up 1, 2, 3. Okay, and what we want to do is figure out a way to find the distance between those 2 points. Okay, and what we'll see is what we need. If we look here, we have a right triangle, and we should be thinking about the Pythagorean theorem. Anytime you see a right triangle, the first thing that should pop in your mind is, I need the Pythagorean theorem. Okay, so here we need the Pythagorean theorem. So to get it, we need the length of some sides. So if we look at this one, this length here, of this bottom leg, it's going to be a length of 1, 2, 3. And to get it, how you get it is you take the x-coordinate of, let's call this A. So A equals the big x-coordinate there, 4, minus the first x-coordinate of 1. 4 minus 1. Because it's this piece right here, which is this whole thing, 4, minus the piece you don't want, 1. So it's going to be 4 minus 1. And if we call this side B, which that equals 3, so we have 3. And if we call this side B, here, its height is going to be here, which is going to be 3, that whole thing, minus that little piece there. So 3 minus 1. So it turns out, if you look here, let me do it in a different color. So 3 minus 1. So it equals 2. Keep being green. Okay? So what we want to find is this third side, C. So we know from the Pythagorean theorem that a squared plus b squared equals c squared. Okay? And we know that a is 3, so 3 squared, and b is 2 plus 2 squared equals c squared. 3 squared is going to be 3 times 3, and I don't think we need a calculator. That should be 9. 2 squared is 2 squared, 2 times 2, which is 4, equals c squared. Okay, and 9 plus 4 is 13, equals c squared. And again, I don't want to find c squared. What I'm looking for is c, so I take the square root of both sides. We can do anything we want as long as we do it to both sides. And let's get a good approximation of square root of 13. .606. So C approximately equal to 3 point, what was it? 606. Okay. So that was just an example to see how this works, because I think it's a little easier than just jumping right into it. So we see to get the leg, the horizontal leg here, we find the difference in the first coordinates, or your x coordinates, or however you want to think about this, the difference in that first coordinate. And then to get the vertical portion of the triangle, of the right triangle, we use the y coordinates. Okay? So let's look at this distance formula one more time. Let's do that all again. Actually, let me just leave that. No, I need to get rid of it. Okay, now let's develop the formula for the distance formula. Distance formula. Okay. First, again, we want to draw the coordinate plane. Here it is, in all its glory. I was hoping to put arrows on there. I like the arrows. So let's call this the origin. Let's plot a point here. Let's say this thing is x1, y1. So that is, it's over x1, up y1. And then we have this second point here. Let's say it's over x2, up y2. And what we want to do is find the distance between those 2 points. Okay? So again, here we see if we can easily construct a right triangle that involves that length that we're looking for here, and it'll be the hypotenuse for this right triangle. And looking at this right triangle, it should be clear that this base here is going to be this whole length x2 minus this length x1. So if I call this side A, I have that A equals x2 minus x1. Okay? And let's switch colors here for this side. Let's call that B. And we see here that B is going to be the whole length of y2 minus that y1, and that will leave me with that length there. That is the side of my triangle. So we get that B equals y2 minus y1. And if we call our hypotenuse C, we get that a squared plus b squared equals c squared. And if we solve for c, because we're wanting to find that length, we take the square root of both sides. And we bring the c over on the other side, and I get that c equals the square root of a squared plus b squared. So c equals the square root of a is x2 minus x1. It is that a is here, x2 minus x1 squared, plus b is here, y2 minus y1 squared. And again, I could have just given you this formula from the beginning, but I think it makes a lot of sense and it's less memorization, and you can kind of get it on the run when you understand that it's just a simple application of the Pythagorean Theorem. And that's going to conclude this video on an introduction to the distance formula.